So now we're going to talk about differentiability and continuity. And so we're talking about the idea of the derivative and continuous, and we want to know what relationship, if any, exists between these two ideas. So we're going to start by defining the derivative of f at c is f prime of c. It's the limit as x goes to c, f of x minus f of c over x minus c, provided this limit exists. But remember, in order for this limit to exist, we need that the one-sided limits, the left-hand limit and the right-hand limit, exist and are equal to each other. So, in order for this limit to exist, we need that the one-sided limits exist and are equal. So we're going to start by looking at a function we graphed previously. This function right here. And remember, it was this function that was made up of these steps. So I'm just going to graph part of the function here. From 0 to 1. My graph looked like that. 2. Had these step pieces where one end had a filled-in circle and the other end had an open circle. Okay, so if I look at x equals 0, I know that this function is not continuous at x equals 0. Okay, because when I draw it out, right, when I get closer to 0, I have to pick up my pencil. There's a non-removable discontinuity at x equals 0. And also, this function is not differentiable at x equals 0. So let's see why that's true. To see why that's true, we're going to have to use the one-sided limits. As I approach 0 from the left, well, if I'm approaching from the left of 0, my y values are negative 1, and so this would become the limit as x goes to 0 from the left. Negative 1, f of 0 is just 0, negative 1 over x, and we learned that this limit would be infinity. And now let's look at the right-hand limits. Well, if I'm looking at the right of 0, over here, my y values are all 0. So I get 0 over 0, or just 0. And the limit of 0 is 0. So here, on one hand, I got infinity. On the other hand, I got 0. These were not the same values. So that's why my function is not differentiable at x equals 0. So you might wonder, does this always happen? What's this connection going on here? And there's this theorem in your book, Theorem 3.1. It says, if f is differentiable at x equals c, then f is continuous at x equals c. So if your function's differentiable, it would have to be continuous at that location.